Right. So like with number 2 and number 3, start looking through some of these, and Brenda's going to get me a copy of the review that she sent you guys so we can make sure that we're looking at the same ones. That way you can just say which question number it is. But if we look at some of the questions. Oh, did you? Okay. Okay. Oh, yeah. Yeah, that's a good idea. Okay. Okay. Right. Right. And that's, yeah. So that's actually a very common mistake that's made. So remember that the absolute value means the distance away from zero. And so absolute values are going to be positive answers. Because if you think about, can you go run -7 miles? That's impossible, right? So we use absolute values to just kind of say it's a distance. So if we just look at this part, forget about the negative that's on the outside, but just the absolute value of -7. Well, -7 is 7 places away from zero. And then after you do the absolute value, then you times it by the negative. So the answer would be -7. So it's kind of like these absolute values. You know how in order of operations we do what's inside parentheses first? Same thing happens. Absolute value are a type of, parenthesis, if you will, grouping symbols. And so you'll always want to do that first. So that's a really good one. Yeah, to look at there. So another one that's kind of commonly missed, and that's down on number, well, let's see, she might have it different on hers. So I'm just going to write it down here. So if you had negative, oops, what happened there? So if I have -4 squared like this, and -4 in parentheses squared. Can you, yeah, can you not see it? It seems to be sharing it with you. That is really weird. Yeah, it says it's sharing. Ryan, you can see it? Mm-hmm. So where are you? Oh, can you see it now? Okay, I know sometimes there's weird. I wonder if it's just if it's kind of going slower or something, if the video is trying to come through on your hotspot. So so this is another common one it's missed a lot because the second one is really saying take -4 and times it by -4, right? And so a negative times a negative is a positive. So this would be +16. Where over here, just the 4 is being raised to the second power, not the negative. So it's kind of like it's saying -1 times 4 squared. And so then you'll do the, order of operations tell us to do the exponents before we do multiplication. So 4 squared is 16, and then we times it by the -1, and it gives us -16. So just keeping those two straight, your mind is going to be, I think really helpful on a lot of the problems. Correct. And the one that's inside. Correct. That's correct. All right. Were there a couple of other questions that you wanted to look at? I mean, there's definitely, I mean, I want to look at the ones that you want to look at that you looked at to that point, and then I'll just start working through some of the ones that I know, students kind of struggle with. Okay. No, and this one actually is another one that you're right. It's a little bit tricky on how to do this one. So for number 10, I mean, I guess I don't want me to just do A. They're both pretty much the same, and then you can try B on your own. So it says, let's see. So I have 3 over 4. Is that the one you're looking at? Plus 9 over x. Now, can you see any of this yet or no? Okay. And I mean, I'm recording this and I'm going to just upload it to my YouTube channel. And I'll give the link to Brenda and she can send that to you too, if that's going to be, helpful for you. Yeah. So since the denominators, right, are different, we need to have common denominators in order to add them together. One way we can find a common denominator is just by multiplying the two together. That's not always going to give us the least common denominator, but it'll always give us a common denominator. So what are you thinking the common denominator is here? Yeah, so if we rewrite it, so I have 4x there, and then 4x here. All right, I'm going to try and change pens. Sometimes the color was a little crazy, but so it's a little bit easier to see. So that means in order to get this 4 to be 4x, right, I'll times that by x, which means I need to times the tops by x. So I'll really have 3x on the top of that first fraction. And then on the second fraction, right, to get x to be like 4x, what do we need to do to it? Yeah, so to get the x to change to be 4x, our common denominator, what do we need to multiply that x by? Yeah. And so that means that on the top, right, we'll have the 3x plus 36, and we can't combine those together because they're not like terms. So we just have to leave it like that, and then just with the 4x on the bottom. And so that's your answer. And I know it looks really weird, and a lot of times people try and, like reduce things down from there and stuff, but you can't, because you can only like divide things out when everything's all connected by multiplication. So since it has an addition sign, we can't do that. So that's all done. Does that make sense? Okay. Yeah, and it is different, like you said, when there's a variable on the bottom. A lot of students are like, okay, I can do it if there's numbers, but just keep in mind it's really the same idea that you're doing there. Get that common denominator, and then once it's the same, now you can add them together. There, is there another one you wanted to look at? Uh-huh. Okay, well, maybe let's just start going through some of these that I have planned to do just because I just know that it's, I just picked some that I know students kind of struggle with, and, usually we can. I am, so if you want to, right. Yeah. Oh, okay. So you're only connected by the phone now. All right, well, if you can write it down on yours, I'll definitely read it out loud to you so that you can see it. So All right, so I wanted to talk about order of operations because that seems to be one that a lot of students make a mistake with on there. So one of which is something like this, where it says 13 plus 2, and then parenthesis 1 minus 3. So the 1 minus 3 is inside parentheses. So oftentimes on this, students try and add the 13 and the 2 together first. All right, what should we do first on this one? Yeah, and you could do that because that would be using the distributive property. But making it even faster, you could do what's inside the parentheses first, right? Because remember, our order of operations are parentheses, exponents, multiply and divide from left to right, and then add and subtract from left to right. So, yeah, so we'd want to do the 1 minus 3 first, right? So that would give us a negative 2. And now let's distribute that 2 through. So 2 times negative 2 gives us a negative 4. And then we'll have 13 plus a negative 4, which would be what? Positive 9. It is. Yep. Yep. Okay. And then let's look at another one with the order of operations because this is another type that seems to get confusing. So if we have 12 and then divided by 2, parenthesis, negative 3. So on this one, there's nothing to do inside the parentheses because it's the negative 3 that's inside there. So those parentheses in this case mean what? Why are those parentheses there, do you think? So if we have the parenthesis, right, that's going to tell us we're going to be multiplying there. And so this is where some people get confused because they're thinking, okay, so order of operations, right? The only two operations we have here are divide and multiply. But sometimes people think, oh, I have to do multiplication before I do division. But that's not true. You do multiply and divide from left to right. So in this one, you do want to start off, yeah, doing the 12 divided by 2, which gives you 6. And then take that 6 and times it by the negative 3. Correct. Yep. But do you see you'd get something totally different if you did the multiplication first? Yeah. And going from left to right. Yep, exactly. Yep. Okay, and the same thing with add and subtract. It's from left to right. So it doesn't mean you always do add first and then subtract. So, all right, what about, do you remember how to find the mean, median, and mode? Okay, right, right, that's correct. And then the mode, Yep. So make sure you don't have that. Yeah. And so there can be no mode if none of, if none of the numbers appear most often, or there can be more than one mode. So, you had like 3 2s and 3 8s in the list that you have, then your mode would be 2 and 8. Okay. And yeah, just make sure you have that memorized, what these things are, the mean, median, and mode, have them separated out in your mind. Because most of the times people are like, okay, I remember kind of what it is, but I can't remember which one's which. So I just caution and make sure you have that really well. All right. And then let's look at some simplify. So write this one down. If we have negative, oops, no, negative 2 parenthesis 3x minus 4 plus 4 parenthesis 5x plus 1. Do you want to read it back to me and see if you got that? Oh, sorry, I should have said, and so the 3x minus 4 end parenthesis, and then plus 4 parenthesis 5x plus 1 end parenthesis. Exactly. Yep. So we can't combine the 3x and the 4 together because they're not like terms. So that means we need to use the distributive property. Right? So go ahead and do that and then tell me what you come up with there. Yep, you do the negative 2 times the 3x. Yeah, so go ahead and you can multiply numbers together that aren't like terms. So negative 2 times 3x is a negative 6x. So you can go ahead and combine that together. It's just with adding and subtracting. They have to be like terms. Oh, yeah, for the final answer. Yep. Would be, yep. Oh, you can? Okay. It's kind of coming through. All right. Looks like had a couple more people join us. Brandy, can you hear me? Okay. So Brandy can't hear. All right. So feel free to chime in, Brandy, on any of this too. And then I see Britt also. Britt, can you hear me? All right. Okay, well, let's keep working on some more of these. So I want to do one more with the order of operations. Let's see. Quite like what I wanted, but so let's try. All right, let's try one like this. So if I have two, oops, see that? That's crazy. I don't know what happened there. Okay. All right, so this one says 2 minus 6, and then parenthesis 9x plus 3. Okay, so where would we start on this? Yeah, so yeah, we're not going to combine those, like the 2 minus 6 together, right? That's what a lot of people try and do. So we do want to start off distributing this. So we're going to take that negative 6 and distribute it through to the 9x, and the negative 6 distribute it to the 3. Right, so that's going to give us, so we still have the 2 out here. And then what's negative 6 times 9x? And then we've got the negative 6 times 3 gives us the negative 18, or minus 18. And then we can just combine our like terms together. So 2 minus 18 gives us negative 16. And then the x doesn't have anything. Yep. And it doesn't matter which way you put it, if the x is first or second. I just always like to put my x's first, but it would be correct either way. Okay. And remember that, so there will be some multiple choice questions on the test, and they wouldn't give it to you both ways, right? They wouldn't give it to you as negative 54x minus 16 and then negative 16 minus 54x. It would just be one way or the other, so it won't be trying to trick you like that. Okay. All right. Let's go down and do a little bit with algebraic expressions. So I know that sometimes, when you have words and you're trying to translate things from English into math, it gets a little bit tricky. And one of the words that is the trickiest is that word from, right? If you're saying, something's being subtracted from something else, it always tends to throw people off because it's really, you're writing things kind of down backwards than the way it's said. So if we have this, a number subtracted from negative 14. Right, so this from, like I said, is word to watch out for because it kind of makes you, have to do things a little bit backwards. So what I mean by that is when you see that word from, the number after it is going to go first, right? And whatever number is in the front is going to go second. Oops, I don't know what happened there, why it didn't. Okay, so that means we'll have negative 14 and then subtracted, right? So we'll have minus, and then a number, well, that's what we don't know for sure, right? So we'll just call that like n or x or whatever you want to call it that way. That looks really weird. Getting used to trying to write on this little tablet. It's so much different than writing on the board. Okay, so that's just a word to watch out for. Like I said, that one tends to be, people usually will write this down as n minus a negative 14, which means something totally different. So watch stuff like that. And then let's try and find, let's look at this next one. I want you to see if you can help me translate this, and then we'll solve it. All right, so this one says the sum of twice a number and 6 is 4. Okay. So then we're going to want to find the number, but first we need to translate this. So I don't know if Brandy, if you're not in a place where you can talk to us or not, you can enter in the chat if you can't. So where would be a good place to start with this? How do you think we translate this? Okay, so you found that word is, right, which is our equal sign. And so that's always a good thing to find. And so the stuff that's to the right of our is goes on the right side. And then the words that are on the left of is are on our left side. And that can be flip-flop, but usually people just write it this way just because it's easiest. So how do we do twice a number? So the sum of twice a number and 6. Okay. Uh-huh. Great. That's exactly right. Okay. So x equals negative 1. All right, but usually if something like this is asked on the final exam, they'll want you to, write out what the translation of it is first. So make sure that you know this part and then solve it. Don't just do that in your head, otherwise you'll miss some points on those. Okay. Yeah, show it all, Even on the multiple choice one, I mean, it might not make a difference on that, but you'll just, if you can work step by step, you'll do much better on it. And maybe while we're talking about a few things, I just wanted to give you maybe just a few reminders that would be really helpful to know. Just make sure that you're following directions and give the answers as they're stated. I know on exam 2, there were a lot of students that just didn't notice that it said, right, your answer is a mixed number or round to the certain place value as a decimal. And so people were missing points just because they just didn't read the question all the way closely. So just watch those things. And make sure you remember all your labels too. You're going to be docked if you don't have your labels. Yeah. So like feet and inches squared, percent, dollar signs, anything like that. Or even if it's like, whatever it's talking about. If it's a story problem, for sure, make sure there's some kind of a label on there. And then the other thing that I noticed on the last test too is just students weren't reducing their fractions all the way. So they were missing some points on that. And they probably didn't need to miss that point. I think that they knew how to do it, but they just didn't show it. So just watch that closely on there. And then the word of oftentimes will mean multiply. And I think sometimes people get a little bit confused by that. So if it says something like, find 3/5 of 65. All right, that's really saying what is 3/5 times 65. So that word of right? In this context, if it's saying find 3/5 of a number, or with percentages, you'll see that word of a lot, okay? And so then on this one, you can kind of see that we need to do some reducing here. So 5 will divide into 5 once and into 65 13 times. And you might go about it a different way. It doesn't matter how you end up getting there, but then you'll notice that once you do that, you'll get 39 for your answer. 3 times 13 is 39. So just watch that word of. It's a little word that sneaks up on people and they're like, what am I supposed to do here? So, all right. All right, let's maybe look at a little bit of story problem. So look at one like this. I'll just read it because it's a little bit long, but then I'm going to draw a picture that kind of illustrates it. So it says a rectangular field is 2 times as long as it is wide. If the perimeter of the field is 450 feet, what are the dimensions? All right, so if we, oh goodness, I keep hitting something and I don't know what I'm doing. I don't know why it keeps doing it. Okay, let me see if I can draw a rectangle now. Best rectangle I can draw with this silly thing. All right, so if it says that one side is 2 times long as it is wide, well, that's telling me I don't know how wide it is, so I'm going to call that W, and the length would have to be 2W. Did that just disappear? All right. It's doing that. Okay, and so then the other information that we know is that the perimeter is 450 feet, right? Oh, wait a minute, yeah, 2 times the size. All right, and so I'm just going to write inside here. So perimeter, we know, is 450 feet. All right, so how do we find the perimeter of any shape? Yeah, so if I have 2W plus 2W plus W plus W, right, and then that's going to equal 450. So when I combine all of these together, I'm going to have 6W equals 450, and then divide by 6. And remember, you'll be able to use a calculator on the final exam. Just make sure it's only a scientific calculator. You can't take a graphing calculator into the test. So what's 450 divided by 6? Okay. So that's 75 feet, right? So we want to remember our label there, and that's the width. So how do we figure out what the length is? So we're doing 2W. Oops, that looks like a subtract sign. Okay, so that will be 150, right? And then how could you check your answers to make sure it's right? Yeah, exactly. So if you can do that, then you'll, be able to, just double check and make sure that you have those. Okay. All right. Let's do maybe a little bit with some fractions. How are you guys feeling about fractions? You feel like you could use a little more review with them, or is there other areas you'd want to focus on? Yeah. Oh, yeah. Yeah, exactly. Well, we'll definitely get to some of that too. Let's start off just by simplifying fractions like this. Oops, this was also something that was kind of on the last test that seemed to throw some people off. So if it's just telling you to simplify it, it just wants you to reduce it. And so one way to go about doing that is to find the prime factorizations of those numbers, which I think oftentimes is the easiest way to make sure that it's reduced down all the way. So 60 could break down to be 6 times 10, right? And then 6 can break down to be 2 times 3, and 10 is 2 times 5. Okay, what about 96? Sometimes you can tell that it too will divide into it because it ends in an even number. Right. Do you know 2 times what? Mm-hmm. Right, and then that can still break down more. So 6 times 8, 2 times 3, and then 8 always goes down to 2 times 2 times 2. You can take in 2 steps if you want, the 2 times 4, and then 2 times 2. All right, so when we're writing this out, right, so I'm going to just write like big fraction here. So on the top, I'm going to use my prime factorizations for 60. And I'm going to put them in order from smallest to biggest. So 2 times 2 times 3 times 5. And then I also need to break down my letters. So I have A times B times B. And then on the bottom, my prime factorization. Let's see, how many 2's do I have there? It looks like 4 of them. Nope, 5. Missed the one up on the top. And then times 3. And so then I can just start dividing out and stuff that I see that is the same. Oops, I didn't mean to kind of go that direction with it, but that's all right. Okay, so 3's divide out. Oh, whoops, I forgot my letters on the bottom. I still have an A and a B on the bottom that I forgot to write down. So I have A that will divide out and a B that will divide out. Now what does that leave us as far as our answer goes? The 3 canceled out. Mm-hmm. Uh-huh. Yep, 2 disappeared there. I don't know why sometimes this pen, it like disappears there. Yep, but that's what you end up with, 5b over 8. Okay, so it's not, came back for a minute, but then didn't stay. Okay. All right. Another one that just want to make sure is clear. If you have, negative 4/5, and if that's inside parentheses, and it's asking you to square it, right, that's really just saying take negative 4/5 and times it by itself. And again, this is one that I saw that was missed quite a bit on exam 2, because a lot of times people are just forgetting that this negative times a negative makes a positive. And so your answer in the end is going to be positive, not negative. So negative 4 times negative 4 is positive 16. And then 5 times 5 is 25. So just watch your positive and negative signs carefully. And I'd say, like, you have plenty of time on this test to complete it, so I hope you don't feel rushed, because usually when you feel rushed, that's when mistakes start happening. Okay. Let's try another one like this, again with fractions. So if I have 3/7 plus 5 over 21, And this is a compound fraction, so it's like fractions on the top and then fractions on the bottom. So on the bottom I have 8 over 9 minus 7/3. Okay, so again, the top part of this compound fraction says 3/7 plus 5 over 21. And then that's all divided by 8/9 minus 7/3. So one thing that you can do is kind of treat these as two separate problems and just look at the top, the 3/7 plus the 5/21, and just do that and get that down to be one answer before you work on the bottom. So in order to do that, we need to have a common denominator. And so here, right, 21 is going to be the common denominator. So if I'm trying to rewrite these, blank over 21 plus blank over 21, well, on this first fraction, I'll notice, well, I need to do 3 times 7 to get it to be 21. So I'll do 3 times 3 to find my new top number. So I get 9 over 21. And then on the second fraction, 21's already on the bottom, so there's nothing I really need to multiply by. I'm just multiplying it by a 1, really. All right, so I just keep that as 5 over 21. And now I can add those together. So 9 plus 5 gives me 14 over 21. Okay. And now we'll need to do the same thing for the bottom. So what would our common denominator be here? Yep. So if we rewrite this as blank over 9 minus blank over 9, all right? So 8/9 stays the same, but we need to multiply that 3 top and bottom. So that gives us 8 minus 21, and with 9 on the bottom. So what's 8 minus 21? Yeah, and make sure you remember that negative. So that's easy to forget about. And now we're still, right, this is divided by, right, so there's still this division problem that's happening. So now we really have this 14/21 divided by negative 13 over 9. And you could go ahead and simplify this top fraction if you wanted to, but not totally necessary yet. I'm going to go ahead and write this division as a multiplication question now. So I'm going to have the 14 over 21, and then I'll need to flip, right, the bottom fraction to be 9 over negative 13. And now, since it's connected by multiplication, you can do the prime factorizations of those and divide them out that way. Or, you know, there's a lot of different ways that people learn to do this. Yeah, so it's easier to do the prime factorization here while these numbers are still smaller because they're connected by multiply. So it actually will be easier here because then you'll do 9 times 14 and you'll get this number, and then you'll have to break it back down to 9 times 14. That makes sense. So yeah, so at this point, this is where you can start doing that. So 3 times 7 is 21, and then negative 13 is prime. Oops, 3 disappeared there. All right, so then what do you see that will divide out? You see some 3s. There's a 3 on the top, a 3 on the bottom, and also 7s. All right, so that means the final answer there, 2 times 3 is 6 on the top, and negative 13 on the bottom. And that would be your answer. What questions do you have on that? What's that? 6 over negative 13. Hello, Nicole. Uh-huh. And it still should work out to be the same, but so did you get to 14 over 21 and then 9 over negative 13? No, the negative only stays with one number or the other. So you put it on the top or the bottom, but not both. So it doesn't matter if you could have negative 9 over positive 13. That's the same thing. But make sure you don't put it with both. Because 14, uh-huh. And then you're going to have this really big number and it's going to be hard to break down. And so, but then in the end, you're going to be breaking it down again to, 21 and negative 13. So that's why I said at this point, once it's connected by multiplication, you can just make those smaller numbers, do the prime factorizations of the smaller numbers. But yeah, if that's, I know sometimes it's like, no, I just need to do the way I've done, and that's totally fine. Uh-huh. And that, but it's one big fraction. Uh-huh. So you have on the top, so on the top you really have 2 times 7 times 3 times 3. It's just one big fraction because anything on the top you'll be able to cancel out with anything on the bottom. Mm-hmm. Yep, you got it. Yeah, I mean, yeah, sometimes when you get those big numbers though, then you break them down the wrong way, and so I just think it's easier just to start from there. But I know if it's just like, nope, that's not going to work for me, I've been doing it this other way, then I totally get that too. And, do it whatever way you feel most comfortable with. Okay, let's do one like this now. So let's do it with solving an equation with a fraction in it. So if I have x minus 5/8, and then that equals 1/6. Yeah, 1 over 6. So x minus 5/8 equals 1/6. So since x is connected by 5/8 by a subtraction, we're going to want to add that 5/8 over. And so I'm thinking ahead a little bit going, okay, wait a minute, if I'm going to add fractions together, what do I need to have? Yeah. So I'm going to write this down. So I'm going to show I'm adding the 5/8 over to the other side, right? But really what I'm doing, actually, I'm going to put it up here. But really what I need to do is get that common denominator before I can add those together, right? So what is a common denominator with 6 and 8? Yep, 48 would work. 24 would also work, but it doesn't matter which one you pick. In the end, you'll just end up having to reduce it more. So if 48 is the one that comes to you, then, use it, whatever works best for you. So I'm going to have this as, are you going to use 48? Yeah. Yeah, that's okay. I mean, it gets you there. So don't even worry about it. All right. So then that means we'll have to do 8 times 6 to get 48. And so we'll times by 8 on the top. And then on the other fraction, we need to times that one by 6. So that gives me 30 on the top. And so then really here, when I add, now I can add those together because they have a common denominator. So 8 plus 30 is 38 over 48. Okay. Now, am I done here? Yeah. So this is what I'm talking about. On the last test, a lot of people left it like this and didn't reduce it, and then they missed some points there. So what can you see, or how do you want to go about reducing this? Uh-huh. Let's see, it's 48. Yep. So 19 over 24. Okay, awesome. So try not to let those fractions freak you out. I know sometimes when students get into the test, they're like, that fraction is just freaking me out, but just treat it as any other number and just try and, take them from there. So um, let's see here. Let's talk about these next. So let's say that we have, I'm going to ask you if these are the same or different. What do you think here? So if I have negative square root of 36, is that the same thing as square root of negative 36? Yeah. So this time we have so the first one has the negative on the outside of the square root, and the second one has the negative on the inside of the square root. Yeah, right. Because, yeah, it doesn't exist. Yeah, it does not exist, or it's not a real number. You can say it anyway, because when we're taking square roots, remember we're thinking of what number times itself gives us 36. So 6 times 6, right, gives us 36. So that's why the square root of 36 is just 6, and then you bring down that negative and multiply by it. But on the second one, right, there's no two numbers that you can multiply together that will give you negative 36. Because if you do negative 6 times negative 6, that's a positive 36. All right, and you can't do 6 and negative 6 because those are very different numbers. You can't. So that's why it doesn't exist. Okay? So just keeping those straight. And maybe while we're on the topic of kind of some of these things, I want to make sure that this other thing is clear. If you have 0 divided by 5 and 5 divided by 0, right? So we have 0 divided by 5 or 5 divided by 0. All right, so if I wrote these as fractions, it's a little bit easier to see it. But when you do 0 divided by any number, you just get 0 for your answer. But what happens when you divide by 0? Yeah. So that one, right, you can't do. You can't divide by 0. So that would be undefined. All right, so just kind of keep it, these are just things that oftentimes show up on the final exam in different ways. And so it's just, good to kind of remember these little things that you're like, oh, wait a minute, which one was this? All right, let's maybe do a few. So remember, on the test, you will be given a conversion and formula sheet, and so it will give you like all the conversions for the U.S. measurements and the metric measurements and the conversions between U.S. and metric, right? So anything that you need there. It also gives you stuff about time, but then it also lists some formulas on there. It's best to try and have all those formulas memorized. that you need to know on there, but because it doesn't tell you what's what. I mean, it'll say like A equals 1/2 BH, which is area of a triangle, but it doesn't tell you that's area of a triangle. So I'm saying that the formulas are there, but they're not telling you which one is which. Does that make sense? So just make sure that you know, like, which one's which. And so let's do some with the formulas right now. And so let's find the area of a circle. Oh my heck. You're lucky probably because you can't see this, Emily. Sometimes this is getting a little crazy. No, the other people, I can see people on, but nobody's talking, so I don't know. All right, so the area of a circle. All right, so when we're asking the area, yeah, what is it? What's the formula for that? No, that's for circumference. So area is pi. That's okay. It's pi times radius squared. Okay, and remember, squaring the radius is different than timesing it by 2, right? Because you're timesing it by itself. So that's where the difference is in that formula compared to the circumference. So if we're told that the radius is 3 feet, all right, then we just need to put 3 in place of our r there. So we'll have a equals, and what are we're going to just, don't use the pi button on your calculators, just use 3.14. Otherwise you're going to get this big, long, crazy answer that's hard to, yeah, right, or 3.14 times 9. Right, and then from there you can just do that on your calculator. These aren't ones that, you don't need to show the work on that. You can use your calculator for it. And then what does that give you? Yeah. And just watch to see if it's asking you to round to a certain place value. But the label on this, right, it was feet, but since it's area, it's going to be feet squared. Whenever we're talking about area, it doesn't matter whether it's a triangle, a rectangle, a circle, area of anything is always, that label is squared. And that's easy to leave off that squared. Okay. All right, let's do one with circumference also, just to show you the difference. So circumference, remember, is around the outside of the circle. But on this one, if it's asking you to find the circumference when the diameter is 4 inches. Yeah, and so, yeah, exactly, because it's giving us the diameter, right? So that one, so 3.14 times 4. That's all you have to do on that one. Yeah, so circumference, right, is just going to be just the label itself. So no squared or anything because it's not, it's not area. We're trying to figure out around the outside edge. So it's just 12.56 inches. All right. Brandy and Nicole, if you can hear me, please feel free to ask any questions that you have or chime in. I know some of you might be at work and not able to, but you can, we'd love to hear from you. All right, let's also look at one using the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. And you can only use the Pythagorean theorem for a right triangle. All right, so that means one of the angles has to be a 90-degree angle. And then the two legs, right, the ones that are hooked to that 90-degree angle, are our A and our B. And our hypotenuse, I know it's a crazy word, right? At the longest side of the triangle, or the one directly across from the 90-degree angle, is always our C in this. So just keeping straight in your mind which one's which is a big deal on this. So let's say that we're given a triangle, a right triangle, where one of the legs is 12 feet and the other leg is 16 feet, and it wants us to find the hypotenuse. So it doesn't matter which one, whether you call 12A, or 16A, just as long as you remember those are the legs. So we'll have 12 squared, if I put it into my Pythagorean theorem, plus 16 squared equals c squared. All right, now I'm trying to solve for c, but let's first get the stuff on the left side of the equation figured out. So what is 12 squared? Yeah, and what's 16 squared? Okay. And then when I add that together, okay. So remember that now we have 400 equals c squared, so we still don't know what c is, right? And so the way we undo squaring something is to square root it. So if I square root 400, that's going to give me my answer. Would be what? So what's the square root of 400? Or did we find area? Was it asking us to find area on this one? Area is the inside of the triangle. Like if you were going to try and carpet, yeah. So that means nope, you're right. 12 squared plus 16 squared equals c squared. So we need an equation there so we can solve for c. And then just as you go down, then underneath 12 squared, right, you're 144. And underneath your 16 squared, right, you're 256. Right? And so then in the very last, after you add them together, you have 400 equals c squared. And so if you square root both sides, well, the square root of c squared is just c, because we're Yep, it is 20 feet, but not 20 feet squared, right? Because there's no longer a squared there, and we're not dealing with area, so we know that the answer can't have a squared in it. Okay. Good question though, because that can get confusing. All right. How about let's talk about finding a better buy. Which one's the better buy? All right. So I know, so that probably means it'll be on the final, right? So let's try this. So if we have 25 fluid ounce of detergent is $3.99. And then we also have a choice of a 90 fluid ounce container of the same detergent, but this one's $6.99. So $6.99. All right, so when it's asking you to find the better buy, what you're really finding is the price per ounce. So that means you always want to have whatever the price is on top, you know, or your first number, so that when you divide it, you have it in the right order. Because usually the thing that happens on this is people are like, okay, I know I need to divide it, but I don't remember which way I need to divide it. So for the first one, right, in your calculator, you'll just put in 3.99 divided by 25, which gives you what? Okay, so 0 point, sorry, say it one more time. Okay, and then if it tells you to round it to the appropriate place, well, on this it would be to the nearest cent, right? Is what we're trying to figure out. How much does this cost, you know, per ounce? And this is in cents. So you see, if we have the 159, right, that 9 is really going to round that 5 up to be a 6. And so we're saying that this one is 16 cents per ounce. Okay, so that's one of our answers. And then the other one, let's figure out. So now we'll do 6.99 in your calculator divided by 90. So now we have 90 fluid ounces. Yep, so let's just write the okay, so what does it say on your calculator? So point, yeah, so that, yep, exactly right. Yes, yep. All right, does that make sense? And just making sure that you're rounding it. Yes, exactly. Yeah, you're like, that doesn't, what is that even telling me, right? So, yeah, I mean, that's always a good thing to do if you're like, I know it's one way or the other. And I know students kind of do that with some questions. They're like, well, I know this is either multiply or divide when it's a story problem, but they can't tell which one it is. And then they try it both ways and they're like, well, that answer doesn't make any sense. So it's got to be the other way. So, you know, I mean, so use that to your advantage. Think about, you know, does that answer make sense on these story problems? Because if not, then what's another way you can do it? All right, let's talk a little bit about proportions too. Proportions are actually so nice because it just is two fractions that are set equal to each other. So if you have 3 over 8 equals 9 over x. Okay, now notice this doesn't say multiply. This isn't a multiply question. It's 3/8 equals 9x. So in order to solve for x on this, the easiest way to go about it would be to do cross multiplication. And you can only do that when it's connected by an equal sign. Right? You don't want to do that if it's a multiplication sign. So that means that we'll take the 3 and the x, we're multiplying along the diagonals. So we've got 3x on one side of my equation equals the other diagonal, 8 times 9, which is 72. And now that equation looks a lot easier to solve. All right, so what would we do from there to solve for x? Yeah, and what does that give you? Yep, so x equals 24. Your answer there. And it doesn't matter if, you know, I mean, they might do something like this with decimals or you know, or maybe even in a story problem that happens. Let's see if I can see a story problem on here. That would be good. Yeah, so let's do this one right next to it here. So if a 3.4 ounce brownie, I'll write this down so it might take me a minute. Has 204 calories. How many calories are in a 9 ounce brownie? Okay. So we're going to set this up as a proportion. We're going to have one fraction equals another fraction. And you want to keep things consistent. So meaning on, you know, like I want to keep the same things on the top, same things on the bottom. So if I'm talking about the size of the brownie, right, and I'm going to put that on top, and it doesn't matter if you have it on top or bottom, but keep it consistent. So on my first fraction, I'll have 3.4 on the top, and then on my second fraction, I'm going to have 9 on the top. So those are both in ounces, right? And then the bottom, we're talking about the number of calories, right? So with 3.4, we said that's how many calories? Yeah. So we'll have 3.4 over 204 equals 9 over x, because we don't know how many calories are in that 9 ounce one. But we're going to solve this the same way that we did the one that we just did before this. So just cross multiply. So do 3.4x equals 9 times 204. Uh-huh. Yep. In the 9 ounce brownie, right? Having issues. And so this is what I'm talking about too with labels. I mean, you know, don't just leave it as 540, like write out calories. 540, you know, calories, just to make sure. Oops. All right. All right, let's do some conversions maybe. Well, actually, let's do one more kind of story problem that I want to make sure. So percent increase and decrease is a question that seems to get missed a lot on the exams and sometimes shows up on the final. So when you're dealing with the percent increase or decrease, there's kind of 3 steps that you can follow to find it. So I'm going to write those steps out, talk about those steps first, and then we'll do a problem with it. So the first step is you always want to subtract the 2 numbers that they give you. Then you're going to take that answer and you're going to divide it by the original amount. And it's really important that you're always picking whatever the original amount is.
Is the formula going to be on that sheet?
It is not. So, yeah, so this is one that you've really got to know. So this is percent increase or decrease. Because there's not really a formula per se for it. It just, but you need to know how to do it.
Is this the one where it's like the ending amount minus the starting amount divided by the starting amount?
Yeah, exactly. Okay, so the percent increase or decrease, right? And then, yeah. And then just make sure that you're always writing your answer as a percent, because that tends to be part where people forget to put that little percent sign there and then they miss it. So, all right, so let's see, if we say, you know, a company decides to give each employee a 5.2% salary increase. Oh, wait a minute, that's not the one I wanted. All right, I thought I had. Oh, here it is. A home was purchased for $250,000. A few years later, a dip in the housing market, it sold for $235,000. What is the percent decrease of that house? So, like you said, we're just going to start by subtracting those numbers first. So 250,000 minus 234,000 gives us what? So 250,000 and 234,000. Was the 250. Uh-huh. Nope, just always do the biggest number minus the smallest number, because you're going to have, you know, your answer is going to end up being positive, and then you'll just have to, you know, notice that it's a percent decrease, but we don't want that negative number on there. You would end up with a negative. Okay, yeah, that's fine. Uh-huh. Yeah, as long as you don't put that, as long as you don't put that negative on in the end, you'll be just fine. So, yes. Sorry, I'm trying to write this on here and it's like, okay, well, good. So as long as you know, have a way that's been working for you, just keep doing that, and, you know, as long as you remember that on there. Because, yeah, like I said, oftentimes it shows up, so it's good to just make sure. All right, so how do you feel about the conversions, like with metric or US or between the two? Yes, it's true. Yeah, but yeah, but all the information would be there. Yeah. Okay, let's try just a couple, you know, different types here. So if I say, let's, so how many, let's see, 176 ounces equals how many pounds? So if we look on our conversion chart, right, we know that 1 pound is 16 ounces. Right? So how did you go through doing this? I mean, there's a lot of different ways that you can. Uh-huh. Right. And your ounces canceled out, right? That's the whole reason why you did it that way. And then, yeah, so 176 divided by 16 is what? Okay. All right, let's do another one here. Let's try doing 56 inches equals how many yards? Mm-hmm. 56 inches. Uh-huh, that's right. Yep, so 1 foot, right, over 12 inches. And 36, so 56 over 6, right? If you're just multiplying across the top and across the bottom. Oh, yeah, yeah, yeah. Sorry, you had it right, and it disappeared on me. I didn't even look back to see what that was supposed to say. Yeah, you're right. So it should be 36. And then on this one, you're going to have to, yeah, round it like to the nearest tenth or something like that. So what would that be rounded to the nearest tenth? Uh-huh. Yep, 1.6 yards. I'll bring those labels. All right, let's see. What about with, how are you feeling about the metric system? I'm not sure. I mean, there is kind of an easy way to do the metric system, and just kind of remembering a little saying just will help you be able to move the place values where you need to. So if we, King Henry died by drinking chocolate milk. So the first letter of each of those words stands for, the stuff in the metric system. So, kilo, hecto, deca, and then the base unit, and then deci, centi, milli. And it will have, like I said, I mean, that will be on the review. I mean, sorry, on the formula sheet that you're given. So you can just kind of see, where that is. But really all you're doing is moving place values. right? So remember, base unit could mean meters, liters, or grams, depending on what you're. It just says base unit. So you've got to remember, like that the base unit is meters, liters, and grams. So, but then it'll show, like deca, hecto, kilo, deci, centi, milli, because those are just the prefixes on any of those, right? So if we try doing one where we're doing 8.9 kilometers equals how many oops, put kilograms. Okay, sorry, milligrams. So 8.9 kilograms equals how many milligrams? So so kilo to milli. So you're going to end up moving that decimal 6 places. Uh-huh. And then fill in those other parts with 0. Yep. Yeah. Okay, so let's do 324.5. Let's do centimeters equals how many kilometers? Yep. Yep. Is correct. Kilometers. Yep. So yeah, so just moving that decimal point is really all you're doing on those. Do you want to try one more or? Yeah, yeah, the chart will be on there. So yeah, 2.2 pounds equals 1 kilogram. Right. So because we've just yeah. So you just need to make sure you're using the 2.2. That's what's given on the sheet. I mean, it is actually more precise to say 2.205, but we're not taking out that many place values because it's not even exactly that. We're just approximating. Um, it shouldn't be. So let's all right, let's maybe do some with All right, so let's change, like try and change from one to the other. So let's say if we go 75, so I'm sorry, 75.8 liters equals how many gallons? So we'll still start off with that 75.8 over 1, right? Sorry, liters. I'm not sure I said that. So 75.8 liters over 1. And then do you have like conversions right there in front of you that you can see? Or okay. Mm-hmm. Yep. Yeah, so like it'll tell you where to round to, so let's round to the nearest tenth. What was it again? I'm sorry, I was writing stuff on. But what did you get on the 20 point? Yeah, yep, no, you're right. So just 20. Or you can put it as 20.0, but usually on something like that, it'll just, just saying 20 gallons would be great. All right. You want to try another one like that? Like, okay. Let's do. Let's see. Why is this not? Okay, let's go 4 inches to centimeters. 4 inches equals how many centimeters? Mm-hmm. Yep. Yep. Because we always want to make sure that those labels will cancel out, right? Because you got inches on the top and inches on the bottom. So yep, you got it set up right. And then just multiply them. Mm-hmm. Okay. So yeah, just being able to use those, I mean, it's really the same thing that you were doing, when you were changing, between like inches and feet or, pounds to ounces and stuff like that. It's just you have different conversions. And like I said, all of the ones that you'll need will be on the test. So don't worry about memorizing any of those. And then, let's see here. I think maybe let's do, so if we do subtracting some units, so if I ask you to subtract 3 feet 8 inches from 8 feet 7 inches. All right, so that word from comes up in this. And that means that you have to write this backwards, right? And if you don't write it, the other way, then you're going to end up with a negative number, which, would be kind of weird on this to say that we have a negative length. So make sure you have your 8 feet 7 inches on top and minus your 3 feet 8 inches on the bottom. But now we can't do 7 inches minus 8 inches, right? So what is it that we have to do at this point? Okay. 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 Uh-huh. Right. Yeah. So that works on that. I mean, because otherwise you're going to end up having to borrow, and sometimes people don't like doing that, like borrowing 12 inches from the 8 feet so that you have a bigger inch to do there. But yeah, you can always just change them, you know, all to inches or, whatever it might be, and then divide like that. So that's great. Let's see. Trying to think. So I've kind of gotten mostly to kind of the last chapter there, unless there's other things that you guys want to look over. I know I just kind of skimmed through some stuff, but okay. Well, one of the other students wanted to look at number 39 on this review, so let's take a look at that one, see if you can find anything else there that you want to look at. No, it's not, but we can definitely do some percent problems. But it is a story. Oh, yeah, it is. So this says a wire is 20 centimeters long and it's cut into 2 pieces. The longer piece is 4 centimeters longer than the shorter piece. Find the length of the shorter piece of wire. So I'm just going to draw kind of a picture here. So here's my wire, and then I'm going to cut it into 2 different pieces. And it doesn't matter, where I put that cut. It's just to kind of help me visualize what's happening. So I don't know how long the shorter piece is, so I'm just going to call that X. But I know that my longer piece is 4 centimeters longer than the shorter. So that means it would be X plus 4. So however long the short piece is, plus 4 more. Right? And then, so we know that the whole thing together is 20 centimeters. Okay. So then to set this up, if you're going to set it up kind of in an equation form, well, you'd say, well, I know that X plus 4 plus X, right, both parts of the piece of wire have to equal 20 centimeters. And then I can combine my like terms and solve from there. So X plus X is 2X plus 4 is 20, and then I'll subtract 4 from both sides. So I'll get 2X equals 16, and then I'll divide by 2. So X equals 8, and we've got to make sure we remember our labels. So 8 centimeters, and X is our shorter piece, is the way that we kind of labeled this, and that's what it's asking us to find, but it could have easily asked us to find the longer piece, so just make sure that you notice on something like this if it wants the shorter piece or the longer piece. But this one is, so 8 centimeters is our shorter piece. Did you want to look at a percent problem? Because we didn't do too many of those. And definitely show up on the final. Like figuring out taxes or commissions or stuff like that. Yeah. Nope, they're not. So let's go over something like that. So if we're changing a fraction to a percent, right? So if I say, let's change 9/25 to a percent. Yep, and then times by 100. Yep. But if we go, let's see, other way. Well, one thing with percent and decimals, right? So if I say, convert 0.3% to a decimal, right? I mean, it's a percent, there's a decimal in it, but it's still a percent. But if you're going from a percent to a decimal, which way are you really moving that decimal point? Yeah, and it's always two places, right, with percent. So then our answer would be 0.003 is the decimal. And the way that I kind of, tell my students to remember this, because sometimes people get confused whether you're moving it to the left or to the right. But think about the alphabet. If you had the alphabet written in order, A, B, C, D, and then a lot of other letters, and down further is P, right? So if you're thinking of just kind of, if you're going from a decimal to a percent, so going from D to P, you're moving to the right, if you had that kind of spelled out. Does that make sense? And if you're going from a percent to a decimal, you're moving to the left. So it's kind of a silly way to help people remember, because they just, especially in testing situations, they're like, wait a minute, which way am I supposed to move this? All right. Let's try one more with some percents. Make sure that we're good on this. So how much tax was paid on $184 car radio if the sales tax is 6.25%, and then so I want you to find how much sales tax and the total. Uh-huh. Mm-hmm. So did you say $11.50? Yeah, okay. Yep. Because you're just doing that 184 plus the so yeah. And just watch, like I said, just make sure you're watching the questions carefully, because sometimes like people will find the tax but then forget to add it back in to know how much the total is, and it's a two-part question, so you'll miss the whole other, second part of that. So make sure on that it is written as money, though, because also Another thing that you'll be docked off for, if you put just 195.5 and not 195.50, right? Because with money, we always have two places after the decimal point. So just watch that closely too. What were you going to ask? It is. Yep. That's the same exact thing. And dividing by 100 is moving the decimal place to the left two places. Mm-hmm. Yeah, let's try one like that. So if it says like 34.2% as a fraction in simplest terms, right? So like you said, you're going to write 34.2 over 100 because percent always means out of 100. But then we need to move that decimal point on the top to be to the end. So we don't want it to say 0.2. We want that decimal point to be after the 2. So that means we're moving it one place to the right, which means we also need to move the bottom one place to the right. So you really have, yeah, go ahead and tell me. Just just 342. We were just moving it one place to move it to the end. So 342 over 1,000. Does that make sense? Yeah, you should have only done it by 10 because you're just trying to move that decimal point right to the end of it. I mean, it would have been the same thing if you did, I guess, the same thing to top and bottom. Just give you bigger numbers to simplify in the end. If you put 342 over 10,000, or sorry, 3,420 over 10,000, that would be the same thing. But then you have to reduce this, right? So that 342, you might want to do the prime factorization of it. Well, we can tell that 2 divides into it, but you might want to see if something bigger does. But if not, you can just start there. Yeah, yeah. Yep, so we'll have 171 times 2, right, on the top. It's 171 breakdown. I think it does a little bit more. Let's try and divide it by 9. Okay, so then on the top we have 2 times 9 times 19, because 19 is prime, so we know that can't go down any further. And then 1,000 is just like saying 10 times 10 times 10. So when you break that down, it's going to be 2 times 5 times 2 times 5 times 2 times 5. So there's really only the 2's that end up dividing out on top and bottom. And what are you left with? That's okay. Just keep doing what you're doing. You're fine. Yep, that's it. All right, how are you feeling about graphing lines from the last section, the last. Oh, you did? Okay, good. Yeah, because that's probably the only other thing that, you haven't touched on yet is just doing those. Just make sure that, I mean, it's going to ask you to, give some kind of a like little chart or give a couple of, points there. So if you were asked to graph like x minus 4, or sorry, x minus y equals 4. All right, and so if it wants you to find two ordered pairs and then graph it, how do you go about finding ordered pairs for that? What did you do? Okay. So x minus y equals 4. It has to graph that. Uh-huh. Yeah, they can be like, yeah, infinite amount of possibilities. So you just need to pick two or three, to put on your point. So yeah, so yeah, because so 6 minus 2 gives us 4. Yep. And so make sure that you're writing those down as ordered pairs, is what I'm saying. So like when when it asks you to write ordered pairs down, you just need to put 6 comma negative, or sorry, 6 comma 2, right? So just don't forget about, writing it as an ordered pair inside parentheses, and then 5 comma 1, and then just plot those points. Okay, good. All right, well, good. If you want to send me your your email, Emily, I can send you this conversion formula sheet because, I mean, I send it to my students beforehand so they know what they're working with. So that way you know what you need to still memorize and what you don't. So, yeah. So feel free to just send that to me in the chat or something there. And I can email. Okay, yeah. Good, I'll write it down. Actually, let me just stop this because I'm recording it.